Brightstorm has thousands of high-quality videos covering all major subjects. Please check out more at www.brightstorm.com.
We're going to be talking in this pencast about what the heck is an extraneous solution. You've probably heard it used in class, maybe in your textbook, and you just want to review what that is and why it shows up. Well, when you have functions in math that have domain restrictions, meaning numbers that break the laws of math, and I'll tell you what that means in a second, you have to watch out for extraneous solutions. Now, in particular, there's a couple key rules or a couple key laws of math. One is that thou shalt not divide by zero. If you have a zero in the bottom of the fraction, something weird's going on. So if you have any x's in the bottom of a fraction and you're solving an equation, you need to check for extraneous solutions. Same idea with square roots we're working with here. If you have a square root of a negative number, we call that no real solutions. Thou shalt not square root a negative number. So what we're looking for here is what would happen if you get x solutions solving algebraically that are actually outside the domain. So first, let's look at this equation, and we're going to try to solve it using graphing calculators, meaning graphing y1 is equal to square root of, now you might need parentheses here, it depends on your calculator, 5x plus 4, and y2 equals x minus 4. Now, you're going to want to make your window for x something like, I don't know, -5 to +15 or something, because you'll see that the place where these lines intersect, my graph here is not to scale, they intersect out here at about x equals 12-ish. So what that tells you is that the key idea is, in this, my intention here, is not showing you what exactly the solutions are. Of course, you could find out what they were by doing second trace, those two buttons. This is on a TI graphing calculator to find where they intersect, which I think is number 5. You could do it that way to find precisely where they intersect. My intention, though, is to show you they only cross at one place, right? These two functions only cross right here. Look what happens if I solve this problem algebraically. Let's just say that instead of graphing calculatoring, which isn't a real world, I just made that up, let's just say that I wanted to solve this algebraically. And the way we solve these equations algebraically is make sure the square root's all by itself, make sure it's isolated, and then to undo the square root, we're going to square both sides. When we square root both sides, the squaring and square rooting are opposite operations. And then on the right-hand side, I'm going to have to do x minus 4 multiplied by itself. So here's what it would look like. On the right-hand side, I'm going to FOIL and combine like terms. I'm kind of skipping a step, so if you want to try this on your own, you sure can there. Set it all equal to 0. And again, I'm going through this pretty quickly, so if you don't trust me, which I don't blame you, you might want to try this on your own. When I solve this factoring, I get x minus 12, x minus 1. So zero product property, I think my solutions are 12 and 1. And a lot of students, when they do these problems, they tell me those are their answers. They cross when x is 1 and also when x is 12. But no, the heck they don't. Look back at your graph that you did on your graphing calculator. Look what happens when x equals 1. X equals 1, they're not even close to each other. X equals 12 is where they cross. So 1 is what's called an extraneous solution. It's something you get when you solve this problem algebraically. I did all of this algebra here correctly, but it gave me a solution that in fact doesn't make sense graphically. So always when you're working with either radical equations, which is square roots, or I mentioned earlier something where you have x on the bottom of a fraction, you need to make sure that your solutions work. You have to go back and check your work either algebraically or graphically, because these types of functions have domain restrictions.
By 2. I can't do this with you two laughing back there.
Work it, work it.
So if we had, no, that's not right, 3 coplanar points.
So have you ever gotten off an airplane? That should be less than. Yeah. Dang.
Is it like 500 degrees in here or what?
All right, so when you're in chemistry class, you're going to be doing a lot of work. You're going to be starting over.
So as an example, we could consider like you've got a chain hanging from two fixed.